Hello, welcome back to Quiffatech Lab. Today's topic is about one of the most fascinating machines that we all know as a supercomputer. Someone may ask, what is supercomputer? How does it function and where is mostly used? Well, this channel will answer all your technical wonders. Well, a supercomputer is a type of computer that has an extraordinary processing power far beyond that of a standard desktop or laptop computer that we daily use. In other words, a supercomputer is a high-performance computer designed for specialized computationally intensive tasks, such as those that require significant amounts of data processing or mathematical computations. On a previous video, we discussed the purpose of invention of computers. Over the years, supercomputers have become a vital tool for scientific research, government agencies, and businesses globally. These technical systems are typically used for tasks that require massive amounts of compute power and storage, such as climate modeling, quantum physics simulations, weather forecasting systems, server farms, and big data analysis. Okay, now, let's explore the details of what makes a supercomputer to be so different from a regular computer. Well, you'll be surprised that it's just the size and the level of processing power. While an average desktop computer or laptop operates with just a couple of processing units, most supercomputers are designed with thousands of interconnected processing nodes, allowing them to function at a much higher speed. So the most powerful supercomputers today can perform trillions of calculations every second, enabling researchers to tackle complex mathematical problems in physics, chemistry, engineering, and other fields. Supercomputers are also frequently used to create complex visualizations, predictions, and simulations of phenomena that would be impossible to observe in reality, helping us to better understand the world around us. When we look at it specifically, these machines are designed to process vast amounts of data and computations, allowing them to analyze, visualize, simulate, and process data at an exponential rate, making them one of the most important technological advancements of our time. But the question still stands, how does it really works? Well, let's begin with the core, shall we? The answer lies in the sheer amount of processing power they are able to bring to bear on any given task. Unlike traditional computers, which rely on a single processor to do all the work, supercomputers are built from the ground up to be massively parallel systems. This means that they are made up of tens of thousands of processors, each of which is able to work on its own part of the problem simultaneously. In order to make all of these processors work together seamlessly, supercomputers rely on sophisticated networking technologies that allow them to transfer data and coordinate their activities in real time. This is no small feat, given the immense amount of data that is typically involved in supercomputing projects. One of the key challenges of building a supercomputer is ensuring that all of the processors are working together effectively. This requires sophisticated software that is able to distribute computing tasks across the various processors, monitor their progress, and ensure that they are all working together in a coordinated fashion. Perhaps one of the most important features of supercomputers, however, is their ability to process data at incredible speeds. This is achieved through the use of specialized hardware, such as graphics processing units, GPUs, and field programmable gate arrays, FPGAs, that are able to perform certain types of calculations much more efficiently than traditional processors. In overall, supercomputers represent some of the most advanced computing technology on the planet. They have the power to transform the way we approach some of the world's most complex problems, and they have the potential to drive breakthroughs in fields ranging from medicine to materials science. Now let's have a look at mainframe computers and their importance in today's world. First of all, let us look at what is a mainframe computer. A mainframe computer is a large computer system that is designed to handle massive amounts of data processing. They are typically used by large organizations for critical applications, such as financial transactions or airline ticket reservations. So mainframe computers also much more powerful than ordinary personal computers because they can handle millions of transactions per second and have a processing power that is more than capable of handling complex workloads. The importance of mainframe computers lies in their ability to handle large-scale, mission-critical applications. For example, some banks use mainframe computers to run their transactions, ensuring that their customers' data is secure and processed quickly. Okay, so how do mainframe computers actually work? Well, mainframe computers typically run on large-scale operating systems such as IBM Z/OS or Linux. These operating systems allow for the mainframe computer to be divided into multiple virtual machines, meaning that multiple applications can run on the same system at the same time. In addition, mainframe computers often use languages such as COBOL or JCL to process data. These languages are specially designed for massive data processing and can easily handle the large datasets that mainframe computers are known for. Let's take a closer look at how behemoths of these computing actually work. The operation of a mainframe computer begins with the operator providing inputs, either through a terminal or a program. The operator enters data into the mainframe system, which is then stored in its memory. The memory of a mainframe is divided into partitions, with each partition sharing a different operating system and applications. These partitions are like virtual machines that can run different tasks simultaneously and independently of each other. So one of the main functions of a mainframe is to manage input-output, I/O. This means the mainframe manages the flow of data in and out of the system. Mainframes have multiple I/O channels that allow them to connect to different input and output devices like terminals, printers, storage media, and more. One of the most significant features of a mainframe is its reliability and its ability to handle large workloads. Mainframe computers can use hardware redundancy so that multiple copies of the same data are stored on separate disks. If anything goes wrong with one disk, another copy is immediately used, ensuring continuous operation. Furthermore, the output language that the mainframe uses is called machine language. Machine language consists of binary instructions that the mainframe can easily understand. These instructions are created by software developers that write programs to run on the mainframe. And that concludes our closer look at mainframe computers and how they work. Finally, let's look at mid-range computers. Basically, a mid-range computer is a type of computer that sits between a mainframe and a microcomputer in terms of computing power and storage capacity. Let's look at it in this way. Mid-range computers are designed for organizations that need more processing power and storage than a microcomputer can provide, but not quite as much as a mainframe. They often use proprietary operating systems and software, and they are typically used for applications such as financial processing, inventory management, and order processing. One of the key benefits of mid-range computers is their scalability. They can handle a wide range of tasks and can be customized to meet the specific needs of each organization. They are also relatively cost-effective compared to mainframes, which makes them a popular choice for businesses looking to expand their computing capabilities. Another advantage of mid-range computers is their reliability. They are highly stable and can run for long periods of time without requiring extensive maintenance or downtime. This is important for organizations that rely on their computer systems to keep their operations running smoothly. Well, in terms of hardware, mid-range computers typically use a combination of high-end processors, large amounts of memory, and multiple hard drives. They may also have specialized hardware components such as RAID controllers for redundancy and high-speed networking adapters for improved performance. Mid-range computers are commonly called as mid-range servers. In conclusion, mid-range computers are an essential asset to organizations and companies that require high computing power for their day-to-day operations. They come with advanced features and functionalities that improve business productivity, and they can be programmed using a wide range of programming languages. This video has come to an end. Thank you for watching, and I hope you found this informative.